Good morning, guys. Welcome back to Science. Miss Higgins here. I want you to think of a time when you were underwater, maybe in a pool or maybe a tub. What was it like? And could you hear sounds underwater? And if you could, that's making me think if sound can travel through water, what other types of materials can sound travel through? So today we're going to investigate how sound travels through things like water, air, and solid objects such as furniture and walls. And we're going to do that by conducting experiments in our sim and reading scientific texts. So first we're going to go to our sim. We're going to play a couple instruments just like last time, and I want you to observe with your eyes and your ears what is happening as the sound travels through a material. Now, a word we might need to describe what we're seeing is the word vibrate. That means to move back and forth very quickly. So let's go to our sim, and we can start with a double bass. Remember, what are you observing with your eyes and your ears? Okay, and let's try the piano. Okay, it seems like each one of these dots are definitely vibrating really fast when we play the piano. In the double bass, they were still vibrating, but it was much slower. It's kind of slow motion, but you can still see that they're kind of shaking back and forth. And in both instruments, each dot isn't moving too much. It's vibrating, but then it crashes into another dot, and then that dot crashes into another one. And they kind of push each other across the screen. Now, if we're studying what sound travels through and how it travels through, what material was sound traveling through just now? As the instrument was being played, what material was that sound traveling through? If you said air, you are correct. So in the sim, the material through which the sound was traveling was air. Now we're going to read a scientific text, and we're going to see if we can learn more about what we saw in the sim. So this is an excerpt from a book called Sound on the Move, which you'll be reading later today. How do messages travel through the air, water, and ground? Many animals send sounds through the air, just like us. Others communicate underwater. Some animals even send sounds through the ground. The air, the water, and the ground are all materials. So is everything else you can touch. Materials are made up of millions and millions of tiny pieces called particles. Particles are too small to see, even with a microscope. We can't see particles, but we can visualize them. The diagram on the next page can help. Particles can move. Even in a solid material like the ground, the particles can move a little bit. Animals send out sounds by moving the particles that make up materials like the air, water, and ground. Let's look at some examples of animal communication. We'll zoom in, okay, and you guys will do that part for your independent work. But something important we need to know is that a particle is a tiny piece of material that is too small to see. Here are some examples of air particles. We know that air is a gas, and so those particles look like this. Here are water particles. We know that water is a liquid, so they look very different than the gas. And these are ground particles. We know that the ground is a solid, so we can see that there are differences on the particle level between solid, liquid, and gas. So based on what we just learned in this text, what do you think the dots in the sim represent? I think they represent the particles of the air. So now let's go back to our sim using what we just learned. This time we're going to click on and select one particle so that we can track what happens to that particle. And we're going to see what happens as we play the sound. And I want you to think, how does sound energy travel from the source to the listener? So let's try with the piano. I'm going to click on this one. So let's click play and watch this one particle. So it started over here. By the end, it came over here. It didn't really move that much. But what I did see was that it vibrated a lot and it crashed into the other particles. Let's try with the double bass. In this one, it actually moved more. It moved slower, but it moved a farther distance. Okay, let's try one more. Let's try the cello. Okay, again, I see that it's crashing into other particles. Another word we could use is colliding. So it's colliding with other particles and transferring that energy across the screen. Okay, so based on our observations, how do we think sound energy travels from the source to the listener? Well, it seems like the particles move and collide with other particles, and they pass or transfer their energy on to those other particles. And it seemed to do that in a pattern. The particles would line up, collide, and then spread apart again in a repeating pattern. It would move just a little bit, then collide with another particle, and then change direction. Now, you guys are going to investigate more about this by reading this book, Sound on the Move. So please read this book, and then you're going to do a jot on the Google Doc. There are just 3 questions you'll need to answer. Slide 4 is in chronological order. So if you could please record the main idea and what the steps were in order. Then in this video, we learned that sound can travel through what material? And then we'll do some cross-source synthesis, and based on the book, what other kinds of things or materials can sound travel through. Good luck and happy working. I will see you next time.